Hi folks, welcome to our live stream. Glad you could join us. For today, we're talking about Smart Building Open Standards 101. So basically like a basic guide to open standards in smart building technology. So yeah, of course, I hope you're going to find it really interesting. We'll go through what some of the topics are going to be in a minute. I hope everyone's having a fantastic week so far. And yeah, just glad you could join me. So while we wait for others to join, as I said, here are some of the discussion points and some of the slides I'm going to show you today. If you want to make comments, please do. I want to make this an interactive session. As I kind of said at the beginning, this is going to be a basic guide to open standards. We're not going to get into like any particular technical discussions. We're going to kind of focus on some of the reasons why we need open standards, how they're implemented, what some of them are and what they do. But, you know, happy to take any type of questions. If you want to add some comments maybe about some more technical aspects, happy to read those out as well. We can go through most of those at the end when I've given the presentation. We're also recording the session. So if you do want to share it with colleagues, that would be great. You're going to find it on LinkedIn afterwards, or you can find it on our YouTube channel as well. If you just search for the Smart Building series on YouTube, you'll find our channel and you'll find the recording there. And of course, if you'd like to subscribe, please do. You can also subscribe to our LinkedIn page as well. And that's actually probably the best way to stay informed about what we're doing and what our research program is for this year as well. So first thing we're going to talk about is the interoperability challenge in commercial buildings. Then we're going to talk a little bit about why open standards matter and how they can help solve the interoperability challenge. Then we're going to look at these three types of standards: building automation protocols, application layer protocols, and what I've called data frameworks, or you might call them data models. And then we can take some questions. All right, so I hope we've got everyone online now. Let's look at the first slide about interoperability. So, you know, a lot of commercial buildings operate with disconnected systems, especially older buildings. HVAC doesn't communicate or interact with, like, say, lighting, or even energy management doesn't communicate and get information from occupancy sensors. There's lots of types of disconnected systems within buildings, and it doesn't create an environment for, you know, having smart buildings. Manufacturers have kind of historically designed their systems to work within their own ecosystems. So, for example, company A, who has a video surveillance system, if you're installing that, they often encourage you to use their cameras, their software. And, you know, if you want to select, let's say, some software from a different vendor, video analytics, you might face some compatibility issues. And actually, this is quite a common situation. Doesn't just exist in buildings. Think Apple, for example. They have a very tightly controlled ecosystem themselves. And it's a trade-off, right? They would argue that the user benefits from a well-integrated hardware and software approach, which gives a better user experience. Others would say that this kind of proprietary approach limits users' options and also isn't really good for innovation. If you want a system just to do a specific task, like so I mentioned video surveillance, if you just want a video surveillance system to monitor your building and record any incidents that happen, then, if you're being offered a hardware and software package that's integrated and is offered at a competitive price, then that might make sense for you in that particular instance. But, buildings generally as a whole are more complicated than this, right? They're a web of different technologies, and there isn't one vendor who is going to be able to supply everything. So realistically, some level or some amount of integration of different systems is going to be necessary. And when you want to connect siloed systems, you're typically then going to come across some expensive custom integration work, or you have to have some middleware platform, or even have to do a complete system overhaul. And of course, cost is always a barrier to adoption, right? So open standards are a way of breaking down some of these barriers and creating more interoperability. So, as I said, why open standards matter, kind of alluded to it there. I think one of really interesting analogy or a way to comprehend open standards is to think about something like Wi-Fi. So obviously we all have lots of Wi-Fi connections in the home, workplace, cafes, and we kind of take it for granted that we can connect to any Wi-Fi network with any device. But that's only possible because we have open Wi-Fi standards. And without those Wi-Fi standards, you would only be able to, for example, use a cafe's Wi-Fi if their router manufacturer matched the manufacturer of the modem in your device, be that your phone or your laptop. Otherwise, there would be no common language between the devices. So you wouldn't be able to connect. You'd have to go and find another cafe. So open standards lead to kind of a more competitive marketplace. So where vendors then don't have to think too much, or where there's like a level playing field with connectivity, then they can compete on the actual merits of their products. So maybe they have better features, more reliability, they offer better support, have better security, or better pricing. Competition is supposed to drive innovation and also keep costs down. It also means that you should be able to select best-in-class solutions for each building system. So maybe you've got vendor A, and that's the lighting solution or lighting control solution that you want to go with because you think that's the best. And vendor B is better at energy management, has a better energy management platform, and you want to go with them. So with open standards, you should be able to choose the best solution for your specific need and know that they can at least communicate together if in that scenario. So while I gave that scenario of like a video surveillance system earlier, like while proprietary systems may have, in the short term at least, have less expensive upfront costs, like really in the long run, open standards should reduce costs. Not just because integration should be simpler and therefore less expensive, but also, as your building gets older, those sort of investments you've made should be able to last a bit longer because you should be able to integrate with future systems as well. So, I talked a bit about the complexity of buildings, right, with all these different systems. We've produced this graphic for a while, and that kind of like speaks to what I mean about that complexity. There's lots of different software applications and platforms and types of software or hardware that control different things in buildings, and ideally they work better together if they can share data and be have some type of connectivity. If the energy management system knows or can see and communicate with occupancy sensors, then they can understand where people are in the building and when perhaps where energy can be saved. Just one small example. So first, look at building automation protocols. So these are kind of like the standardized communication methods that enable a building system to exchange information. So they're kind of like the specialized language that allows your HVAC controls to communicate with your lighting control system, for example. And they serve a really important purpose in the kind of technology stack of the building, and they primarily operate at what you can call like the field level or the automation level of that stack, where they sit between the physical hardware components like sensors or actuators and the management software and that building operators use. The kind of most influential global standard in modern building automation is BACnet, and that was developed by ASHRAE, an association in the US, in the 1990s. I think one of the reasons why it's maintained its popularity and has actually grown its influence is because it has kind of it's well developed. It's well supported. So, for example, they came up with innovations like BACnet Secure Connect, which, because it was first developed in 1990s, things have moved on, and BACnet Secure Connect was able to address some of the cybersecurity concerns that didn't exist when the protocol was first developed. Also, ISO standardization has I think also really helped cement BACnet as the kind of dominant building automation protocol. KNX is worth a mention. It's a popular protocol, especially in Europe, and it was originally designed for both residential and commercial applications. And I think it's fair to say that its popularity at the start was mainly within the residential context. But again, it's got a vibrant kind of community around it. It is constantly being developed, and it's becoming having more use through IP-based and wireless networking solutions. I've also mentioned there at the bottom Modbus. That's sort of like more the elder statesman of building protocols. It dates back to the 1970s. And it was actually originally developed for industrial control systems, which meant that it was reliable and simple. But it has sort of, as technology has developed and we're in this sort of more modern IoT era, I think things have moved more towards BACnet. And I mentioned the technology stack, and this is a graphic that we produced as part of our recent research. So, we talked there about building automation protocols, and they sit at that kind of field automation device level where we've called there the sensor layer and the network connectivity layer. So now, as we move up the stack, we can, and this is sort of like more of the modern approach to the smart building technology stack. We'll talk more about what happens at the data layer and the application layer. So whilst building automation protocols like BACnet handle that kind of device-to-device communication within building systems, application layer protocols are the ones that operate at that higher level. On that previous graphic I showed, the data and application layer. And they're responsible more for formatting and translating data between applications, often across different networks or to the cloud. So you can think of application layer protocols as these kind of translators or traffic managers that move data efficiently between building systems and software applications. And they're going to process, analyze, and visualize the data. One of the most popular at the moment is MQTT, and especially within kind of the IoT applications, mainly because it's a lightweight messaging protocol. It's good at real-time data transmission, and it's not so heavy in terms of bandwidth and has relatively low power consumption. Then there's something called CoAP, which is essentially a lightweight version of HTTP, which is optimized for IoT. And finally, the OPC UA, or Unified Architecture. So this is really interesting, and we did a podcast. If you want to go and look on our Smart Building series channel with Brahm about Unified Architecture. So it's kind of bridges the gap between industrial systems and modern IT environments. So it was originally designed for industrial automation, but its sort of strengths lie in comprehensive information modeling and built-in security features. So it's definitely worth taking a look at. And then finally, I wanted to talk about converging data standards. And I'm going to quote here from Eric Wallin, who is one of the founders of Real Estate Core. He said, in a sense, we have created common languages for devices to talk to one another, but we're still developing common languages for them to organize and remember the masses of data buildings generate and store. So data standards are really provide this common vocabulary and relationships that give meaning to the raw data that our buildings are now generating. So, let me illustrate one of the issues, like with, here you can see the third point down. Like when two different systems maybe have a recording for a temperature reading. So one might label it as RM101 underscore temp. Another one might label it as zone 3 underscore air temp. But they're doing the same thing. They're measuring the same thing. So without a common data model, applications won't be able to recognize that they're the same thing. And data standards have try and solve this problem by creating not just consistent naming conventions, but also like creating a model for understanding what the relationships are between the data. And three of the most popular are Brick Schema, Project Haystack, Real Estate Core. And we're seeing more collaboration between these different kind of data models through initiatives like ASHRAE 223P, which is a proposed standard, again, from ASHRAE, that allows to really aims to provide a consistent foundation of the building data modeling. So a well-aligned set of frameworks could emerge, which would give a clearer choice for building data representation. So I think this is pretty good news for the future of interoperable smart building technology. So that kind of covers the main three buckets of standards that I wanted to talk about. I also want to mention next month, we're going to be publishing a white paper with Real Estate Core. And we're going to be doing a live stream about that on the 15th of May. So if you're interested in learning more about Real Estate Core, how you can use it, then please join us. And if you follow the LinkedIn page, follow our LinkedIn page, we'll be posting about that. And I'll put up a page at some point where you can sign up for that event. Also, you've seen some of the graphics from this report. I just put them in the live stream earlier. If you're interested in a copy of this report, you can buy it from our website. If you scan this QR code, you can go to the page. And and obviously within this report, we will talk in more detail about open standards. Also, if you're considering subscribing to us, we'd love to have you subscribe to our website. If you go to memory.com/subscribe, you can sign up to read all of the research articles that we publish every month. And we offer 2 types of subscription. So if you're interested in all the reports and all of the things we publish, you can have an enterprise license. We also offer individual licenses if you're just interested in what we publish on the website. We also offer advisory services. If you have a requirement for market intelligence, competitive landscape analysis, those kind of things, we're happy to support you with that. Any kind of target screening and identifying potential acquisition opportunities, we can help with that kind of thing. And also, we have developed our own AI system. So we are actively developing that. And if you're interested in accessing our data through an API, access to our vector database where we have stored all of our research data, then talk to us. We're making that available for enterprise subscribers. So we've got a few minutes left. Thanks for listening, everyone. Thanks for getting this far. Let's see if we have some questions. Give me 1 second. Can give people a few minutes if you want to post something. You can also post on YouTube as well if you would like. So yeah, we'll hang around for a couple of minutes if there's anything anyone wants to add. Like, it doesn't have to be a question, can be a comment. Maybe I got something wrong, so feel free to correct me. I think, as I said, we're doing this next month, this white paper with Real Estate Core. I think that's one of the really interesting developments over the last 5-6 years has been this development of data model standards, and I think it's super exciting about the fact that they're converging, and they really do offer a way of modeling building data that is going to be really, really useful for applications. And if you think about it from the perspective of AI, that we know that artificial intelligence is going to have an increasing impact on the software that manages and optimizes our buildings. If those agents, those AI agents that are going to be optimizing workflows, if they don't have access to normalized, standardized data, it's going to make things much more difficult. If we really want to get to a point where we have interoperable, fully automated building controls, then we really do need to standardize the data that our buildings produce, and that the application layer that I showed earlier can use, that all different applications can consume data in a normalized way. That is super important. Let me just last check to see. We've had a couple of comments here. Just one that says, good explanations, thank you. Looking forward to the white paper. One, where can we read more about Open Standards 101? Well, I don't know about a basic kind of explanation, right? That's kind of why we did this video, because I don't think there are that many basic explanations. But obviously, like each of the standards that I mentioned, BACnet, KNX, Project Haystack, Brick Schema, Real Estate Core, MQTT, they all have websites and they all publish a lot of information. They're all open, of course, so you can find out everything about them, from very, very technical descriptions to more about what they do and what their aims are, right? And anyone can get involved in helping support these standards. So there's probably the best way to start, right? Is go to their websites, look through some of the documentation, see if they have kind of like beginners guides to what they do. One more here. I'll just read this out. It looks like a comment. Hi, James. Excellent presentation. Thanks. Could you say a few words about wireless standards, N-Ocean, Zigbee, BLE, Bluetooth, low energy, LoRa, and where they fit into the future, especially with the need for retrofitting the millions of existing commercial buildings and getting the necessary data to make them smart? Well, you kind of answered your own point there. I think like wireless has a really interesting use cases. One of them being retrofitting. These standards are really developing. Like wireless is becoming more prevalent. Can like higher bandwidth and really becoming more mature as standards. So I think that's really exciting, not just from a retrofit perspective, but also potentially even making installation much easier and quicker and again, as I said, the retrofit opportunity. So yes, they definitely have a part to play in this, and I didn't cover them within those three buckets. So yeah, you could definitely add wireless standards as another bucket to the open standards we covered. And also one thing we didn't discuss, I've left off for today, was security standards as well. Very important part of this puzzle as well. There are like some really good cybersecurity standards out there for connected systems. Yeah, okay, one last check. Let's see if there's any more comments. One last one here, which we'll cover. I'll just see if there's anything on YouTube. Yeah, comment here. Can you summarize the difference between Real Estate Core, Brick, or Haystack? We will be doing that in the Real Estate Core white paper. So as I said, they're kind of converging, right? So that's the point of ASHRAE 223P, is that you will be able to use these standards interoperably. So in some sense, it doesn't matter that there are differences, but they come from different backgrounds. They come from different perspectives. Real Estate Core comes more from the property community, property industry perspective. So you can, within that, you can model data about leases, which tenants you have, how long the lease is for, what type of rooms there are. Brick Schema comes more from the technical side. That's more about equipment, actuators, and air handling units. And Haystack comes more from the tagging perspective. So where you're able to tag data in it, add metadata in a specific way. But obviously, that's where each of these started from. They're all being developed and extended all the time. Good. Okay. Well, I think we've reached our half an hour. If there are any more questions, then feel free to put them in the comments, and I can answer them later. Or you can just reach out to us by email or message me directly. Thanks for everyone for listening. Really appreciate you joining today. And yeah, I guess goodbye for now, and happy Easter to everyone. Bye-bye.